Okay, now we are on part C, the last problem. Just for this discussion, we'll continue with mathematical induction. Alright, so here we are proving this statement. This is a statement which is correct, but want to see how correct it is and how we can do that. So what we do is we follow the cases. The first case, we test for n is equals to 1, meaning that you only, for the left hand side, you only consider the part which has n, and this part is this last one, which is multiplying with these other ones. So we have 1 minus 1 over n plus 1. What we do is we say 1 minus 1 here. There we have n, which is 1 plus 1. So this gives us 1 minus 1 over, this is 2. So we are removing half from 1. The result is half. This is left hand side. We now move on to the right hand side. Right hand side, which is 1 over n plus 1. Here, wherever there's n, substitute with the 1. So you have 1 plus 1. So this gives us 1 over 1 plus 1 is 2. Same as the left hand side. So that's what you do with case 1. So case 1 holds. So case 1 holds. Now, since this is true by case 1, it means that it will definitely be correct by case 2. So case 2, this one is an assumption. We are making an assumption that n is equals to k. So what we do is, we'll get this statement. Here where there's n, replace with a k. So we have 1 minus half, 1 minus 1/3, 1 minus 1/4, 1 minus 1 over, where there's n replaced with the k plus 1. This is equals to 1 over k plus 1. Then we move on to the last case, case 3. Here we test again. We are testing for the second time. Now this time around is for n is equals to k plus 1. So what we do is we write our expression, which is 1 minus half, 1 minus 1/3 times 1 minus 1/4 multiplied by, this one will be 1 minus 1 over, here there's n plus 1, since n is equals to k plus 1, replace with k plus 1, here there's n, then we add the 1 there, then everything divided by 1 over, since we have n, you replace with k plus 1, then not forgetting that we're adding a 1. So simplifying this a bit, it gives us 1 like this. So this is k plus 1 plus 1 is 2, equals to 1 over k plus 1 plus 1 is 2. Okay, so look at this. We are multiplying. Now if you look at how it goes, we're always starting with 1, 1, 1, 1. Then there's a negative here for each. What it is that if you look at the denominators, this is 2, this is 3, this is 4. We're ending with k plus 2. The difference for each is a 1. So meaning that we have the first part as 1 minus half. So meaning that the one which just before this would be this one minus 1, since we increase a 1 to this one. So this will give us 1 minus, so when we say 2 minus 1 gives us k plus 1, like this. Then multiply by the last one now. This is equals to that. So this is what we have on the right hand side. Left hand side will have it like this. Again, let's compare this with which part? With the second case, this one here. What do you see? Same results. And this part is equals to 1 plus k plus 1. 1 over k plus 1, sorry. So we'll substitute with that. Okay, now, so from here, what we have next is that this part here is 1 over k plus 1. which is multiplying with the last part, which is 1 minus 1 over k plus 2. This is equals to 1 over k plus 2. So we work with the left hand side. So we maintain this part. This is multiplying with, so for this one you can find the common denominator, which is k plus 2. So 1 into k plus 2 give us k plus 2 times 1, that is k plus 2. Then minus k plus 2 into k plus 2 give us 1 times 1, you get 1. So what do we have next? Next we have 1 over k plus 1 to multiply with. On top here, 2 minus 1 give us a 1, so you get k plus 1. Like this. Then you say over k plus 2. Now what will happen next is that this part and that part will cancel. They are the same. This gives us 1 over k plus 2, which you see to be the same as the right hand side. So we therefore conclude to say this statement is true by mathematical induction. Thank you very much. See you in the next discussion.